The water was darker than either brother had anticipated when they descended beneath the surface that September morning. Visibility stretched only 8 feet ahead through the particulate-filled depths of Lake Michigan's western shore, where legends of sunken vessels had circulated among the diving community for decades. The younger brother led the descent, his flashlight beam cutting through the gloom like a knife through fabric, illuminating suspended sediment that danced in the artificial light like snow in a snow globe. Behind him, his older sibling followed the descent line, both men breathing steadily through their regulators as the pressure increased with every foot they dropped toward the bottom. The lake floor appeared gradually through the murk, a landscape of sand, scattered rocks, and the occasional piece of debris that hinted at human activity from years past. They had studied the coordinates carefully, cross-referencing old maritime records with modern sonar readings taken by a friend who captained a charter fishing boat. The data suggested something substantial rested in this exact location, approximately 63 feet below the surface, in water cold enough to preserve whatever lay beneath for generations. The thermocline had been sharp on the way down, a sudden temperature drop that signaled their passage from the sun-warmed surface layers into the deep cold that dominated these depths year-round. Then the outline emerged from the darkness like a ghost materializing from fog. The tugboat silhouette took shape gradually, its hull encrusted with decades of zebra mussels that had transformed the once smooth steel into a textured landscape of shell and sediment. The vessel sat upright on the bottom, as though it had been gently placed there by some enormous hand, its integrity remarkably intact despite what must have been decades of submersion. The brothers exchanged glances through their masks, excitement evident even through the distortion of water and glass, and began their careful approach toward the wreck. "We're incredibly close to hitting 7,000 subscribers, and your support means everything to this channel. If you're enjoying this deep dive into maritime history and incredible mechanical discoveries, smash that subscribe button and consider becoming a super thanks supporter. It helps us bring you more stories like this one. And drop a comment letting us know where in the world you're watching from. Now, let's get back to what these brothers found in the depths. The tugboat measured approximately 45 feet in length, a compact working vessel designed for the demanding tasks of harbor operations and short-range towing. Its wheelhouse remained largely intact, though the windows had long since disappeared, leaving dark rectangular voids that fish now used as shelter. The deck was a treacherous landscape of corroded metal, collapsed ventilation shafts, and the remnants of equipment whose original purpose was no longer clear beneath the biological growth. The brothers moved methodically, documenting everything with their underwater cameras, aware that each image captured a moment of history that few people would ever witness firsthand. The older brother pointed toward an access hatch on the deck, its cover partially displaced and hanging at an angle that suggested either damage during the sinking or deterioration over the years. Together they approached the opening, their lights revealing a darkened interior space that beckoned with the promise of discovery. The younger brother entered first, angling his body carefully through the opening while managing his equipment and air hoses to avoid entanglement. The interior space opened into what had been the engine room, and the sight that greeted them stopped both divers in their tracks. The engine dominated the compartment like a mechanical cathedral, its 8 massive cylinders arranged in a straight line that spoke of power and industrial elegance from another era. Even under layers of silt and biological growth, the distinctive characteristics of a Fairbanks-Morse engine were unmistakable to anyone familiar with vintage marine power plants. The opposed piston design, the robust construction, the sheer presence of the machinery, everything indicated they had discovered something far more significant than a simple abandoned tugboat. This was a piece of maritime engineering history, a type of engine that had powered everything from submarines to cargo vessels during the golden age of American industrial manufacturing. The brothers spent the next 40 minutes of their dive examining every accessible inch of the engine and surrounding machinery. They noted the serial numbers stamped into various components, photographed the mounting points and shaft connections, and documented the condition of everything they could reach without disturbing the delicate equilibrium of the wreck. The engine appeared remarkably complete, with no obvious signs of catastrophic failure that would explain the vessel's abandonment. Fuel lines remained connected, cooling systems showed no major breaches, and the massive flywheel sat frozen in time, waiting for a force that would never come to set it spinning again. As their dive computers began alerting them to approaching decompression limits, the brothers reluctantly began their ascent, following the line back toward the surface with frequent stops to off-gas nitrogen safely. Their minds raced with questions and possibilities. How had this tugboat ended up on the bottom? Why had such a valuable engine been left to rest in the depths? Was it possible to recover such a massive piece of machinery from 63 feet of water? The surface seemed to approach far too slowly as they contemplated the discovery and what it might mean. Breaking through the surface, they swam to their boat and hauled themselves aboard, immediately pulling out their underwater slates to compare notes and review the images captured during the dive. The excitement was palpable as they examined the serial numbers they had recorded. A quick reference check against online databases of Fairbanks-Morse engines confirmed their suspicions. The engine they had found was an exceptionally rare variant, possibly one of fewer than 50 ever manufactured, and certainly one of only a handful still known to exist in any condition. The weeks following the initial discovery became a blur of research, planning, and consultation with experts in maritime salvage and vintage engine restoration. The brothers contacted naval architects to assess the feasibility of recovery, spoke with marine archaeologists to ensure they weren't disturbing any protected sites, and reached out to collectors and museum curators to gauge interest in preserving the find. Each conversation revealed new layers of complexity to the task they were contemplating, but also reinforced the historical significance of what lay on the lake bottom. Historical records eventually revealed the tugboat's probable identity. Cross-referencing the location with shipping records and maritime incident reports from the 1950s and 1960s suggested the vessel was the Harbor Master 3, a working tug that had disappeared under mysterious circumstances during a routine operation in 1959. Official reports at the time noted only that the vessel had failed to return to port and was presumed lost with all hands, though no bodies were ever recovered. The depth at which it rested suggested a rapid sinking rather than a slow descent, but the upright position and intact condition argued against catastrophic structural failure. The mystery of the crew's fate remained unresolved. Local historians provided context about a major storm system that had passed through the area around the time of the disappearance, bringing sudden high winds and rough seas that had caught several vessels unprepared. One theory suggested the crew might have abandoned ship during the early stages of flooding, perhaps making it to shore or being picked up by another vessel, though no records confirmed such a rescue. The absence of human remains on the wreck suggested either a successful evacuation or that the crew's bodies had been swept from the vessel during the sinking. Planning the recovery operation consumed the next 3 months. The brothers assembled a team of experienced salvage divers, secured a crane barge capable of lifting the estimated weight of the engine and its mounting framework, and obtained all necessary permits from local authorities. The costs mounted quickly, but a combination of personal savings, contributions from marine heritage enthusiasts, and a grant from a historical preservation society made the project financially viable. Every detail required careful consideration: water depth, weather windows, lift point locations, rigging specifications, and backup plans for every conceivable complication. The recovery operation launched on a calm morning in early May, when the lake had warmed slightly but before the summer boat traffic reached its peak. The crane barge positioned itself directly over the wreck site, its stabilizing spuds driven deep into the lake bottom to provide a solid working platform. A team of 6 divers rotated through shifts, each spending carefully calculated periods working on the bottom to attach lifting cables, cut through corroded bolts, and prepare the engine for its journey upward through 63 feet of water. The work proceeded with painstaking slowness. Each attachment point needed to be tested and verified before the actual lift could begin. The engine weighed approximately 8,000 pounds dry, and would weigh considerably more with water saturating every crevice and cavity. The mounting frame that secured it to the tugboat's hull required cutting in multiple locations, a process complicated by decades of corrosion that had fused components together in ways never intended by the original builders. Underwater cutting torches glowed like angry red eyes in the depths as divers methodically severed each mounting point. On the 3rd day of operations, everything was finally ready. The crane operator took up slack in the lifting cables slowly, testing each connection point under gradually increasing tension. On the bottom, Divers watched anxiously as the engine shifted slightly in its corroded cradle, then began its first movement in more than 6 decades. Sediment erupted in clouds as the massive machine broke free from the lake floor, revealing clean metal beneath where it had been pressed against its mounts. The ascent began at a rate of 2 feet per minute, a glacially slow pace that ensured control and minimized the risk of catastrophic cable failure. The engine broke the surface like a breaching whale, water streaming from every opening and crevice as it rose into the sunlight for the first time since before most people on the barge had been born. The crane operator held it suspended over the water for several minutes, allowing the bulk of the water to drain naturally before swinging the load over the barge deck. Divers surfaced around the operation, watching from the water as their weeks of planning and days of hard work reached this pivotal moment. The engine lowered onto prepared supports with surprising gentleness, the crane operator's skill evident in the precision of the placement. With the engine secured on the barge deck, the team could finally examine their prize properly. The 8 cylinders stood in magnificent alignment, each head showing the distinctive opposed piston architecture that had made Fairbanks-Morse engines legendary for their reliability and efficiency. The block itself was a masterpiece of casting work, with cooling passages and oil galleries integrated into the structure with a precision that modern computer-aided design would be hard-pressed to improve upon. Brass identification plates remained legible despite their submersion, confirming the engine's manufacture date of 1947 and its original installation in a vessel built for the Army Corps of Engineers. Transportation to the restoration facility presented its own challenges. The engine's weight required a specialized heavy-haul trailer and careful route planning to avoid bridges with insufficient load ratings. The brothers followed the truck convoy like proud parents accompanying their child to college, documenting every mile of the journey with video and photographs. The restoration shop they had selected specialized in vintage marine and industrial engines, with a particular expertise in opposed piston designs. The owner, himself a collector of historical machinery, had agreed to oversee the project personally after seeing photographs of the engine still sitting on the lake bottom. The restoration process began with careful cleaning to remove decades of accumulated sediment and biological growth without damaging the underlying metal. Each component received individual attention as the engine was systematically disassembled, with every part catalogued, photographed, and assessed for serviceability. Some items emerged from the lake in remarkable condition, protected by oil films or enclosed spaces that had limited water intrusion. Other components showed severe corrosion and required complete replacement or extensive machining to restore proper dimensions and surface finishes. The cylinder liners presented one of the most significant challenges. The opposed piston design meant each cylinder contained 2 pistons approaching from opposite ends, meeting in the middle where combustion occurred. The precision required for proper operation was measured in thousandths of an inch, and decades underwater had left the liners pitted and scored beyond acceptable tolerances. New liners had to be manufactured from scratch, requiring the services of a specialized machine shop capable of working with the unusual dimensions and material specifications from the original blueprints. The brothers located a set of original engineering drawings in a university archive, photocopies that had survived because an engineering student had used them for a thesis project in 1952. The pistons themselves needed complete rebuilding. The aluminum alloy showed corrosion in areas where the protective coatings had failed, creating a lacy network of oxidation that compromised structural integrity. A metallurgist examined samples under microscopy and recommended complete replacement rather than attempting to salvage the originals. Modern materials could provide superior performance, but the brothers insisted on maintaining absolute authenticity, choosing instead to have new pistons cast using period-correct alloys and manufacturing techniques. The additional cost and time seemed insignificant compared to the importance of preserving historical accuracy. Months became a year, then stretched toward 18 months as the restoration progressed through each major system. The fuel injection pumps required specialists flown in from Germany, where a small company still maintained expertise in servicing vintage marine diesel systems. The governor mechanism needed hand-fitting of components, a process that took a master machinist 2 full weeks of careful work to achieve the precise operation required for stable engine speed control. The cooling system received new piping throughout, fabricated from copper-nickel alloy that would resist corrosion better than the original mild steel while maintaining visual authenticity. The electrical system presented its own unique challenges. The original 32-volt starting system used components no longer manufactured, requiring the brothers to scour surplus dealers, maritime salvage yards, and online auctions to locate suitable replacements. A complete starter motor eventually came from a decommissioned Coast Guard cutter being broken up in New Orleans, shipped north at considerable expense but worth every penny for its perfect compatibility. The generator received a complete rebuild, with new windings, bearings, and brush assemblies bringing it back to factory-fresh condition. As components began returning from various specialists and machine shops, the reassembly process finally commenced. The brothers participated in every step, learning from the restoration shop experts while applying their own research and knowledge gained through months of study. They learned to measure bearing clearances with micrometers, to torque head bolts in proper sequence and to specified values, to time the fuel injection system for optimal combustion. Each lesson reinforced their respect for the engineers who had designed these machines and the skilled workers who had originally built them. The crankshaft assembly required 4 men and a small crane to maneuver into position. The forged steel component weighed over 600 pounds and required perfect alignment in its main bearing journals to ensure proper operation. The installation took an entire day, with frequent stops to check and recheck measurements as the shaft lowered into place. Once secured, the connecting rods attached with newly manufactured bolts torqued to specifications that accounted for modern understanding of material properties and stress loads. Each piston followed in sequence, sliding into its liner with precisely measured clearances that would allow for thermal expansion during operation without risking seizure. The fuel system installation required particular attention to detail. Fairbanks-Morse engines used a complex timing system that coordinated fuel delivery to each cylinder at precisely the right moment in the combustion cycle. Adjusting the system required specialized tools and deep knowledge of the engine's operating principles. The restoration shop owner spent 3 days just on initial timing settings, referring constantly to technical manuals and making minute adjustments to achieve the synchronization required for smooth operation. The brothers watched and learned, understanding that this knowledge would be essential for future maintenance and operation. With all major systems installed, the moment arrived to fill the engine with fluids and attempt a first start. The brothers had dreamed of this moment since first spotting the engine's outline in the murky depths of Lake Michigan. Fresh diesel fuel, special break-in oil formulated for vintage engines, and coolant mix flowed into their respective systems. The air starter system pressurized with a hiss that seemed almost alive, building to the pressure needed to spin the massive engine through its first revolutions in more than 60 years. The shop owner took position at the controls, his hand on the fuel lever while his eyes scanned the various gauges and indicators installed around the engine. The brothers stood back, cameras ready, hearts pounding with anticipation mixed with anxiety. So much work, so much time, so much expense had led to this single moment. The starter valve opened with a metallic clank, and compressed air rushed into the cylinders, forcing the pistons to move and the crankshaft to rotate. The engine turned over slowly at first, spinning through several revolutions as oil pressure built and fuel filled the injection lines. Then a cylinder fired, a sharp bark of noise that echoed through the shop like a gunshot. Another cylinder joined, then another, until the 8-cylinder engine was rattling to life with a distinctive rhythm that spoke of power barely contained. The shop owner advanced the fuel lever carefully, watching exhaust smoke color and listening to engine note with practiced expertise. Blue smoke gave way to clear exhaust as the break-in oil burned off and combustion stabilized. Within minutes, the Fairbanks-Morse was running smoothly, its mechanical symphony filling the shop with a sound not heard from this particular engine since the Eisenhower administration. The test run continued for 30 minutes, with careful monitoring of temperatures, pressures, and vibration levels. Everything operated within expected parameters, validating the months of meticulous work and attention to detail. The brothers could hardly contain their excitement, grinning like children on Christmas morning as they watched the product of their obsession running perfectly. The shop owner finally throttled back and shut down the fuel supply, allowing the engine to coast to a stop with mechanical precision that spoke of proper assembly and precise clearances throughout. The following weeks involved additional running and testing, gradually increasing load and duration to properly brake in all moving surfaces and verify reliability. The engine performed flawlessly through each test, its opposed piston design delivering the smooth operation and impressive power output that had made these machines legendary among marine engineers. Final dyno testing confirmed output at 425 horsepower at the engine's rated speed, matching factory specifications from 1947 and demonstrating that proper restoration could indeed bring vintage machinery back to as new condition. The brothers faced a decision about the engine's ultimate fate. Museum offers came from several institutions interested in adding the rare Fairbanks-Morse to their collections. Private collectors expressed interest in purchasing the complete package, engine, restoration documentation, and the story of its discovery and rebirth. But the brothers had developed a deep connection to the machine through their journey from discovery to restoration. They chose instead to install it in a custom-built display in their hometown, where it would serve as both a memorial to maritime heritage and an inspiration to others interested in preserving industrial history. The installation process created a permanent home for the engine in a climate-controlled facility designed specifically to showcase its mechanical beauty. Glass walls allowed visitors to view the machine from all angles, while carefully designed lighting highlighted the engineering details that made these engines remarkable. Interpretive panels told the story of the discovery, the tugboat's history, and the restoration process. Interactive displays let visitors understand how opposed piston engines worked and why Fairbanks-Morse designs were so successful. The brothers conducted regular demonstrations, running the engine for audiences who marveled at the sight and sound of vintage marine power coming to life. The project's success inspired others in the diving and restoration communities. Reports began circulating of other underwater discoveries being investigated more thoroughly, with proper documentation and preservation efforts rather than simple salvage operations. The brothers consulted on several projects, sharing their experience and encouraging historically sensitive approaches to marine archaeology. Their story appeared in diving magazines, restoration journals, and maritime heritage publications, spreading awareness of the treasures that still waited beneath the waters of the Great Lakes and other waterways. Years after that initial dive into murky water, the brothers still reflected on how a simple exploration had transformed into a mission of preservation and education. The Fairbanks-Morse engine represented more than just a mechanical artifact. It embodied the skill of workers from another era, the engineering excellence of American manufacturing at its peak, and the stories of people who had depended on such machinery for their livelihoods and sometimes their lives. Every time the engine ran, bringing its 8 cylinders to life with their distinctive sound, it connected present to past in a way few historical artifacts could match. Before you go, remember we're so close to 7,000 subscribers. Your subscription really does make a difference in helping us share more incredible stories of discovery and restoration. Hit that subscribe button if you haven't already, and consider supporting the channel through Super Thanks. These stories take time to research and present, and your support keeps them coming. Thanks for watching, and until next time, keep exploring.